The next question that is connected with this same passage is two different structures are given. One is in the Fisher projection and the other is in the Newman projection. The question is, how are the two related? These two structures, one which is given in the Fisher projection, the other which is given in the Newman projection, how are the two related? Choose from these four possibilities. Are they enantiomers, or diastereomers, or two representations of the same compound and then constitutional isomers? Now, normally when one is given in the Fisher projection and the other is given in the Newman projection, convert the Fisher projection into an equivalent Newman projection. When we convert this into this, actually this structure will leave the Newman projection as it is. When we convert this Fisher projection into a Newman projection, always convert it to an eclipse. This is what is known as a staggered Newman projection. Now convert this first to an eclipse Newman projection, then make it a staggered. Now first this CH3 is here, this H is here, this H is here, this CH3 corresponds to this, and then this H corresponds to this, and then this OH corresponds to this. This is what is actually known as, that is actually this CH3 is being eclipsed by this CH3, this H is being eclipsed by this H, this OH is being eclipsed by this. We are viewing through the axis between the two bonds. As a result, this is completely what is known as an eclipse form, whereas this is known as a staggered form. Now rotate this group just through an angle. It can be rotated through 60 degrees, 120 degrees, 180 degrees. When you rotate it through 180 degrees, you will find this CH3 comes over here. Then this OH comes over here. This hydrogen comes over to this. So these two structures are the same. In other words, they are not enantiomers. They are not also diastereomers. What is the difference between enantiomers and diastereomers? Enantiomers are those which are object and mirror image, and diastereomers do not have enantiomeric relationship, or they do not have object and mirror image relationship. Stereoisomers, they do not have an object and mirror image relationship, is referred as the diastereomers, whereas this is actually seems to be the correct choice. The two are the two representations, even though I will remove this form, this is the staggered form of the eclipse form. That is actually the eclipse form is first, this is being first converted to the eclipse form, then it is pushed through 180 degrees, then you will get rotated through 180 degrees, then you will get this structure. Therefore, there are two representations of the same compound. So the correct choice for this is, they are not constitutional isomers, there is one and same compound, but represented in two different ways, one in the Fisher projection and the other in the Newman projection.